All right, welcome to section 3.2 part 1, where we're going to learn about log functions, logarithmic functions. I think you've seen this at some point in Algebra 2, but if not, we're going to redo the whole thing. The essential question is, what are logarithmic functions and how do we manipulate them? Okay, so what can we do with these? So what we're going to learn today is, we're only going to do part 1. In part 1, we are only going to do this first one, evaluate expressions involving logs. I didn't even spell that right, so we're going to have to fix that in the notes. All right, so the whole idea of logarithm, it all comes back to this definition, and this definition goes both ways. So it goes from left to right, and it goes from right to left. Okay, so if we have a log base b of x, I don't know, so let's say log base 3 of 9 equals some number, so let's say 2. Okay. It equals to b of y equals x. So the base raised to what's after the equal sign, so 3 raised to what's after the equal sign, 3 raised to what is equal to the number next to log, which happens to be 9. So is this true? Is 3 raised to the second power equal to 9? Looks like it's true. Okay. These are stipulations on logs. These situations must be true in order for the log to work. Okay. The base, b stands for base, must be always greater than 0. The base cannot be equal to 1, and that's like last section, that b can't equal 1 because nothing happens when the b is 1. And the x value must be bigger than 0, okay? Because you cannot raise a number to a negative number and get some answer out. Okay, it doesn't work. All right, so that's the definition. All right, so what we're going to do is we're going to evaluate each log using that definition. Okay, so we have a log here. So basically what we're going to do is 3 raised to what power, after the equal sign, we'll just call it x, is equal to the number next to log, which is 81. Okay, well, what number? 3 raised to what number is 81? Okay, 3 raised to the third power is 81. So my x equals 3. Okay, all right, let's do number 2. 5 raised to what power is equal to square root of 5? So this will take us back to Algebra 2. What exponent is the square root? Okay, so hopefully you remember that it's 1/2. So my solution is 1/2. Okay, and let's do number 3. All right, 7 raised to what power is equal to 1 over 49? And what this does is this takes us back to our negative exponent properties or our exponent properties. So 7 raised to, remember, to get a whole number, down to a fraction, it's got to be a negative exponent. And what does that exponent need to be? How do I get a 49 from 7? Well, you have to raise it to the second power. So remember, that's 1 over 7 squared, which is equal to 1 over 49. So the answer to this one is -2. Okay. All right, let's check the last one out here. So apply the definition. 2 raised to what power is equal to 2? I said what power and I wrote 2. Okay, let me start over on this one. I messed that up. All right, so start again. 2 raised to what's after the equal sign, which we don't know, is equal to 2. Well, 2 raised to what power is 2? Hopefully you can see that 1. 2 raised to the first power is equal to 2. Okay, so our answer is 1. All right, so there are some basic properties of logs. Okay, so basically on this first one, just think about this. Anything raised to 0 is always going to be 1. So when the answer or the number right next to log is 1, you know your answer is always got to be x equals 0 every time. Okay, and when the log, the base, and the number next to it are the same, so think about this, b raised to the first power is always going to be equal to b. So anytime the base and the number next to it are the exact same number, the answer is always going to be equal to 1. Man, this computer's not drawing very good today. I apologize for that. Okay, x equals 1. Okay, and then last but not least, there are 2 properties that you always have to remember. Okay, so anytime you have a base and the number next to it that are equal to the same thing, those cancel out, and your answer is always going to be whatever the exponent is. So for instance, if you have log base 3 of 3 to the 2x power, the log base 3 of 3 cancels, and you're left with an answer of 2x. That is always going to happen. Same thing when you take a exponent and you raise it, so the base is the same as the log base. Those will cancel, and your answer will be whatever's left over. So for instance, 4 raised to the log base 4 of 3x. The 4 raised to the log base 4 cancels, and I'm left with 3x. Okay, so those are two properties that we use quite often when we're discussing logs. All right. So we're going to evaluate each log applying the properties. Sometimes you don't really need to use the properties. Okay, so we're just going to apply the definition. 5 raised to what's after the equal sign is equal to 125. Okay, what number can I raise 5 to make it equal to 125? Well, hopefully you know that 5 cubed. 5 times 5 times 5 is 125. Okay, second one, let's apply the property. 9 raised to what number is equal to 81? This one's really easy. 2. That is annoying. X equal to 2. So I'll let you my computer for some reason today. Okay. Now this next one, okay, is I wrote this wrong. So what I would like you to do is to fill this in. Let me do this. And let me add raised to the, we'll do 3x. Man, my computer is not being very beneficial today. All right, this, we're going to raise it to the 3x. Actually, I'm just going to leave it. I'm just going to leave it. Okay, so what happens if the answer is this? Okay, let's apply the definition. 3 raised to what's after the equal sign is equal to 3. Well, that was pretty easy. It's 1. I'm not going to make it more difficult. Okay. Now this next one is definitely one of the properties here. So remember, anytime you have an exponent that's raised to a log with the same base, they cancel out. So let's see what cancels out here. So when I have a log 12 raised to log base 12, the 12 and log base 12 cancel, and I'm left with my answer of 4.7. Okay, that's a nice, easy property that you should always remember. All right, so now these next two are just the same thing, except they're two different things that the calculator uses. A logarithm with a base 10. So anytime the base is 10, it's called the common log, and this is often written without the base. So if you notice, if there's no base on your log, you assume that it's 10. And this is what calculators use. So if you want to write calculators, okay, that's what the calculators use. So if you're on the calculator and you hit the log button, you're going to assume that it's doing base 10. Okay, it's called the common log. All right, you still apply the same definition. Okay, log base 10. If it's not there, you assume it's a 10. So 10 raised to what's after the equal sign is equal to what's next to log. So 10 raised to y equals x. So if we do this, okay, let's try to solve this one. We assume, since there's no base, that it's 10. So 10 raised to what's after the equal sign, which we don't know, is equal to 100. 10 raised to what power is 100? Hopefully you know that that's x equals 2. Okay, so that's how common logs work. All right, so what we'll do is we will work on some of these examples in class. Let's just do a couple. Let's do the first two. So remember, if there's no base there, we're assuming it's a base 10. So 10 raised to what's after the equal sign, this one doesn't have one, so you just add it, is equal to 1,000. So if the last one, 10 squared, was 100, this one is going to be 3. 10 to the third power is 1,000. Okay. Number 2, 10 raised to after the equal sign, which you just add yourself, is equal to 0.001. Okay. If 10 to the third power was 1,000. What 10 raised to what is going to be the 1,000th? Okay, hopefully you can see that negative 3 would be 0.001. So x equals negative 3. Okay, and you can do that on your calculator. 10, get rid of this, 10 raised to negative 3 is equal to 0.001. Okay. Now sometimes we have to use our calculator like this one. Notice no base. We assume it's 10. 10 raised to what's after the equal sign is 26. I don't think there's any way you can tell me 10 raised to what power is 26. So if you can't, you just use your calculator. So we're just going to do log of 26 on our calculator. Log of 26 is equal to 1.41. 1.41. So x equals 1.41. Okay, so 10 raised to 1.41 should equal 26. 10 raised to 1.41 is equal to 25.7, which is 26. Okay. All right. Last one here. We'll just do them all. 10 raised to what number is equal to negative 5. Now, please don't forget in the log rules. Remember, your x value must always be bigger than 0. You can't have a number. You can't raise something to a power and get a negative number. So this one, if you have to raise something to a power to get a negative number, no solution. Does not work. Okay. And last but not least, we have something. So we just did common log. Now we have what's called a natural log, and it is written ln of x. And what does that mean? It means base e. And remember, e is just a number. So ln of x equals y. This really means log base e of x equals y. So we apply the definition. E raised to what's after the equal sign is equal to what's next to the log, which is x. And that's what the definition says. And don't forget that x has to be greater than 0. So we will save these examples for class. Please remind me to do these when we come around and check. Have a good night, and I'll see you tomorrow.